Hello everyone. In this video I'm going over the Knewton Alta assignment for section 2.5 part 3 called Quadratic Formula. So in this video I'm going to be going through a preview version of this particular Knewton Alta assignment. Please understand that the questions I see in this video may or may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, so the questions should be similar and the way you work on them will be similar to what I'm doing. So I'm hoping that watching me here helps you out in some way when you're working on the assignment yourself. Alright, so you have you're going to see the title, you won't see the words preview of. You'll have your mastery bar telling you how far along you've gotten. You can see your objectives. Right? It looks like there are 2 objectives in this particular section, this particular assignment. And then under the current objective, there is a question related to that objective. And at the bottom of the question, every question, there should be a feedback button where you can send feedback to Knewton if you're seeing anything wrong, any issues with the question or the answer. You will not have an instructor cheat button. Right, that's for instructors only. But you will have a more instruction button, which if you're struggling with a particular topic, particular objective, click on the more instruction button and you'll be taken to a page with further reading or videos to watch, and then you'll have questions related to that instruction. And if you get those right, you'll progress through the assignment just like if you were to get the original one right. So there's nothing wrong with clicking on more instruction if you need to. Alright, so this first question is on the objective: use the discriminant to classify the solutions of a quadratic equation. Alright, so first I want to talk about, again, the title of the assignment here is the quadratic formula. And within the quadratic formula is this thing they're mentioning here called the discriminant of a quadratic equation. So I want to get into all that first. Alright, so the standard quadratic equation looks like this. Right? Or at least any quadratic equation should be able to be written this way. Right? You have some number a times a variable squared plus some number b times that variable to the first power plus and then some number c equals to 0. Right? You should be able to write any quadratic equation in this form. Now, hopefully you recall section 2.5 part 2's Knewton Alta assignment video, because in that I showed you how to solve any quadratic equation by completing the square. So say I asked you, take this equation here, ax squared plus bx plus c equals 0, and I said, solve by completing the square. Now there are going to be a lot of letters thrown around here, so if you can't follow this, don't worry about it. Just wait till the end of it. You're going to see the important thing. Solve by the complete the square method. Alright, so if you recall from the last section, 2.5 part 2's video, first I would get the quadratic term and linear term on their own side. So I'm going to subtract c. So I have ax squared plus bx equals, negative c. And make sure the quadratic coefficient is 1. So if it's a, right, say this wasn't 1, I would just divide everything by a. So we have x squared plus b over a times x equals negative c over a. Alright, then comes the complete the square part, where I take half of this, which would be b over 2a, and square it, which would be b squared over 4a squared. And this gets added to both sides, b squared over 4a squared. And if I want over here, if I want a common denominator, I would have to multiply the numerator and denominator of this fraction by 4a. That way we get 4a squared. So you have negative 4ac over 4a squared. That way I can put them together. Then the whole reason for that addition, that completing the square, is so I get a perfect square trinomial. Right? This expression on the left side is x plus whatever half of this b over a was, which is b over 2a. That quantity squared equals, right, and then over here, the common denominator is 4a squared, and the numerators, when you combine them, would be b squared minus 4ac. And I'm putting the positive one first. Right? Then I can apply the square root property. Right? And again, from the last video, right, section 2.5 part 2, you should know what the square root property is. By the square root property, x plus b over 2a, right, the expression being squared, is either going to be the positive or the negative square root of this expression. Now the square root of a fraction, you can take the square root of the numerator, b squared minus 4ac, and then divide it by the square root of the denominator, which would just be 2a. Right? And technically it should be 2 times the absolute value of a, but let's assume that a is a positive number here, so we don't need absolute value symbols. And then finally I would subtract this b over 2a to get x alone, and we get our solutions. And because these have the same denominator, right, 2a, you can put them together with a denominator of 2a, and the numerators would be subtracting. This would be negative b, and then you have one with the plus, one with the minus, right? There should be two separate solutions here, one with the plus, one with the minus, and then you have the square root of b squared minus 4ac, right? With the b squared minus 4ac all in the square root. This, you may have seen this before in your mathematical career, but this right here is called the quadratic formula. Right, so if an equation starts this way, right, if an equation starts off in standard form like this, where everything's on one side, 0 on the other, and it's gotta be like this, it can't look like anything else for you to use the quadratic formula. It must look like this, ax squared plus bx plus c equals 0. Then you just need to identify your a, b, and c and plug them in here. And your solutions will be the opposite of b, plus or minus, right, again, one with the plus, one with the minus, and then the square root of b squared minus 4 times a times c, right, all that in the square root, and then all of this, big bar, divided by 2a. Right. So if it starts off this way, then you can jump right to the solutions if you know what a, b, and c are, and then of course simplify. So that's the quadratic formula. Right? And you can solve, as you can see right here, a, b, and c are any number I want them to be except 0. A can't be 0. You can solve any quadratic equation just by putting it in this form and then jumping to the quadratic formula. Or you can solve by completing the square. As you see, the quadratic formula comes from completing the square. So either way is fine. Either way is fine. Now, this discriminant they're talking about is the expression underneath the square root in the quadratic formula. So the discriminant of equation ax squared plus bx plus c equals 0 is b squared minus 4ac. It's the expression that's underneath the square root in the quadratic formula. Now, what does this discriminant tell us about the kinds of solutions this equation will have? Well, let's go over these. 1, if b squared minus 4ac is positive, then you'll have the opposite of b plus or minus the square root of a positive number, right? The square root of a positive number is real, right? The square root of a negative number is imaginary. So then you'll have two real solutions, right? If this is positive, the equation has two real solutions. Now we can break this down even further. Let me call this 1a, right? Or 1a, make that capital A. Right? If b squared minus 4ac is a perfect square, right? And by perfect square I mean, 1, 4, 9, 16, 25, etc., right? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. Or even a fraction, a rational number squared. Then the equation will have two rational solutions. You can express the solutions as an integer over an integer. Equation has two rational solutions. And 1b, all right, so still part of number 1, if b squared minus 4ac, if the discriminant is positive, if it's not a perfect square, right, if b squared minus 4ac is positive but not a perfect square, right, so like 2, 3, 5, 6, 7, 8, 10, 11, and so on, but still positive, right? Still positive. Well, then, the square root, right, of a non-perfect square is an irrational number, right? Square root of 2, square root of 3, square root of 5. Those are irrational. They can't be expressed as an integer over an integer. You'll still have real solutions, but they'll be, the irrational type of real. Right? The equation in that case has two irrational solutions. I'll just say two irrational solutions. Okay. All right, so that's case 1. Right? If the discriminant is positive, then ask yourself, is it a perfect square? Is it not a perfect square? Right? Well, I have two rational solutions or two irrational solutions. All right, in case 2. What if it's equal to 0 instead of positive? Right? What if b squared minus 4ac equals 0? Well, in that case, you'll have the square root of 0, which is 0. So you have negative b plus 0, negative b minus 0. So just negative b. You'll have one solution, negative b over 2a. The equation has one real solution. Well, we're going to assume that a, b, and c are rational numbers, so maybe I should have written that up here. Let's just say assuming little a, b, and c are rational, right? Because we're not going to see too many equations where a, b, and c are like the square root of 2 or pi or e or something. So if that's the case, then you take the square root of 0 here. You have negative b over 2a. That's a rational solution. One rational solution, but only one. Just the negative b over 2a, right? The square root of 0 is 0. And then finally, case 3, what if it's negative? if b squared minus 4ac is less than 0, right, it's negative, well then you'll have two solutions where you're taking the square root of a negative number. So you'll have an imaginary number in your both solutions. You'll have something with that I. Remember, the square root of -1 is I, right? Imaginary. Square roots of negatives are imaginary. That's been brought up in previous videos. So the equation will have two complex solutions with an imaginary part, but in this text they're just saying two complex solutions. Even though every number is complex, right? Real numbers are complex by themselves, but when they're saying here the equation has two complex solutions, and I'm going to add the little note with an imaginary part, with a non-zero imaginary part, right? There's actually an imaginary number involved. So I'll just write here with a non-zero imaginary part. Right? But two complex solutions. So your answer choices, notice, right, back here are, two rational solutions, two irrational solutions, two complex solutions. That means with an imaginary. All right, I don't know why I accidentally clicked on that. That might not be the answer. And then a single rational solution, right? So if the discriminant is positive and a perfect square, if the discriminant is positive but not a perfect square, if the discriminant is negative, and finally if the discriminant is 0. All right, so let's write this equation out. All right, I'm going to write this equation out and we'll do it. All right, find the discriminant. Now it's got to be in that form, right? ax squared plus bx plus c equals 0. We have negative 4x squared plus 5x plus 3 equals 0, right? This is in that standard form, ax squared plus bx plus c equals 0. A is the quadratic coefficient, -4. B is the linear coefficient, +5. C is the constant, +3. The discriminant of this equation, and again, if it's not in that form, it doesn't have a discriminant. You have to put it in that form to get the discriminant. Is b squared minus 4ac, right? This is the part that's under the square root in the quadratic formula. So that'd be +5 b squared, right? 5 squared minus 4 times -4 times 3, right? I'm just replacing a, b, and c with -4, 5, and 3. 5 squared is 25, and this would be plus 48. It's positive. I don't care what it is. I just care that it's positive or negative or 0. Right? I guess I should care what it is because I need to know if it's a perfect square or not. Okay, so let's continue. So yeah, 25, and then this is 16 times 3, 48. And then 25 plus 48, that's 60, plus 13, that's 73. So it's positive, but not a perfect square. Right, 64 is 8 squared. That's 8 squared. 9 squared is 81. 73 is in between those. All right, so it's not nice. It's not a nice perfect square. So remember that case when the discriminant is positive but not a perfect square, the equation will have two irrational solutions. All right, and that's all they want. Two different irrational solutions. And you could continue on and actually find the solutions, but that's not what we're asked to do here. Right? So two distinct irrational solutions, right? The discriminant was positive and not a perfect square. And let's check it out. All right, and again, after every question, you'll be told if you're right or you're wrong, and you'll be given an answer. You'll either be given another chance to enter an answer, or you'll be given an answer explanation. Please read through these. All right, whether you're right or wrong, and try to learn from mistakes, for the future. All right, next question. All right, so this objective is actually find the solutions. All right, but remember the first thing, if you're going to use the quadratic formula, the first thing you must do is put the equation in that standard form. Right? Everything on one side, 0 on the other side, and no parentheses, everything's multiplied out. You got a quadratic term plus a linear term plus a constant term equals 0. All right, so I'm going to write this equation out, and we'll use the quadratic formula to solve it. And it's for the variable d. Right? We have 5 times d times the quantity, d plus 1, and then plus 6 equals 0. Right? This is not in standard form yet. Right? So I can't use the quadratic formula. Not yet. I'd have to distribute the 5d here, and that would give me 5 times d squared plus 5 times d, and then plus 6. Now I can. Right, now it's in standard form, ax squared plus bx plus c, but instead of x you got d. Right? You can change the d to x if you want. Alright, so a is positive 5, right? B is also positive 5, and c is the constant term, positive 6. And then I can just jump straight to the solutions. Say d equals, the opposite of b, plus or minus the square root of b squared minus 4ac, and then all of that divided by 2a. And I'm just going to substitute, 5 for a, 5 for b, 6 for c, and simplify. So we have negative 5 plus or minus the square root of 5 squared minus 4 times 5 times 6, all this divided by 2 times 5. All right, now simplify. It's negative 5 plus or minus the square root. Now this is 25 minus 120. So that's a negative number. So this is going to have some imaginary numbers, these solutions. This is going to have an imaginary number in it, the square root of a negative. This is negative 95. Right, negative 95. Now remember, when you see the square root of a negative, you got to rewrite that with that I. That's the square root of the positive, square root of 95 times I. Right, make sure the I is not in the square root. 95 is 5 times 19, so this doesn't break down any further. And then we got 10 in the denominator. So we have negative 5 plus or minus the square root of 95 times I, all divided by 10. And what I'm going to do is since there's an imaginary number here, I'm going to write both answers in the standard form for a complex number, which was a real number. Negative 5 divided by 10 is negative 1/2, and then plus then the square root of 95 divided by 10 times I. Right? There's a real number plus an imaginary number, and then the other with the minus. D equals negative 1/2, right? Negative 5/10 minus the square root of 95 divided by 10 times I. And these are the answers, right? These are the solutions to this equation. And that's what I'll enter. All right, so going back, D equals, and it says separate with a comma, right? So negative 1/2 plus the square root. Gotta actually use the symbol here. The square root of 95. Get out of the square root, divided by 10, and then afterwards times I, comma. Now you can type all that again. What I'm going to do is I'm just going to copy and paste this. Control C, Control V, and just change the plus in the middle here to a minus. There's negative 1/2 minus the square root of 95 divided by 10 times I. And those should be the solutions to this equation. Great. But yeah, it's that simple. You get it in that standard form first, everything on one side, 0 on the other. Quadratic term plus linear term plus constant term equals 0. Identify the A, B, and C, and just pop those into the formula. Now you got to know the formula too. All right, that's half the battle. All right, and again, please read through the answer explanations. All right, next question. Again, solving an equation. All right. So once again, I've got an equation here that's not in the standard form. I got to put it in standard form by distributing the 2n, and then jump into the quadratic formula. All right, so let's go to some paper. All right, so we have 2n times the quantity 4n plus 5, and then plus 6 equals 0. After distributing the 2n, it'll be in standard form, or there'll be 8n squared plus 10n, and then you got the plus 6 still equals 0. And honestly, just to make the numbers smaller, I'm going to divide everything by 2 on both sides, because I notice all the coefficients are multiples of 2. So that gives me 4n squared plus 5n plus 3 equals 0, and I'll use this. Alright, so the value of A is 4, the value of B is 5, the value of C is 3, and we can jump right to the solutions. And again, I'll write out the formula. It'll be n equals, right, the variable's n, the opposite of b plus or minus the square root of b squared minus 4ac, and then all that divided by 2a. And I'm just substituting these numbers and simplifying. So negative 5 plus or minus the square root of 5 squared minus 4 times 4 times 3, 4ac, and then all that divided by 2 times 4. Now that's 25 minus, 48, right, 4 times 12, that's another negative. This is the square root of negative 23, which will be written as the square root of 23 times I, or I times the square root of 23 if you want. So what I have here are negative 5 plus or minus square root of 23 times I, and then all that divided by 8, but they want us to write the solutions in that a plus bi form, right, the standard form for a complex number. So the real number is negative 5/8, then you got plus or minus, and then the square root of 23 over 8 times I, and one with the plus, one with the minus, and we do have to separate them. Right, we do have to separate them. I can't use the plus or minus symbol. All right, so back here, n equals, the real number part is negative 5/8 plus, and then we got the square root of 23 divided by 8 times I, comma. And then again, I'm just going to copy and paste this after the comma, and just change this plus in the middle here to a minus, and those should be the good solutions. And you can check by hand if you want, but they should be good. All right. Great. And again, please read through the answer explanations. All right. Next, back to the discriminant. All right. Again, these should be shorter. You're not doing the entire quadratic formula. You're just looking at the expression underneath the square root symbol. All right, so the equation is already given to us in the standard form, 6x squared minus 6x plus 2 equals 0. If you want to work with some smaller numbers, just divide everything by 2. You got 3x squared minus 3x plus 1 equals 0. That's fine too, right? Divided by 2 on everything. A is 3, B is negative 3. Don't forget negatives are part of terms. And then C is positive 1. And the discriminant is simply the b squared minus 4ac, right? The expression underneath the square root in the quadratic formula. So negative 3 squared minus 4 times 3 times 1, that's 9 minus 12, which is negative, right? Negative 3. And if that's the case, you have two complex solutions, right? That's how they're going to word it. because you'll be taking the square root of a negative, right? Those will be, it's just like the last two problems. You'll have imaginary numbers. You'll have that I in there. So you have two complex solutions with an imaginary part, but they're only saying two complex solutions. Okay, great. Okay, next. All right, back to just using the quadratic formula. Again, we're given an equation that's not in standard form to start with. We just have to do some simple multiplying to get it in standard form, and then we can use the quadratic formula. All right, so this is 8q times the quantity q minus 2 plus 10 equals 0. Distribute the 8q here. You got 8q squared minus 16q plus 10 equals 0. And once again, I'm noticing all the coefficients are even. I'm just going to divide both sides by 2. 4q squared minus 8q plus 5 equals 0. Just to shrink the numbers in the beginning, make it easier on myself. And now that I have it in standard form, I can jump right to the quadratic formula. Q equals the opposite of b, which would be positive 8, divided by plus or minus the square root of, negative 8 squared is 64, minus 4 times a times c, that's 4 times 20. 4 times 20 is 80, right? So another negative number. All that divided by 2 times a is 8. And this is the square root. 64 minus 80 would be negative 16, which is 4i. So we have 8 plus or minus 4i, all divided by 8. If you divide each of those by 8, 8 divided by 8 is 1, plus or minus, and then 4/8 is a half. So you have 1 plus half I, 1 minus half I. Those are the solutions of this equation. And again, you can check by plugging them in and working it out by hand, but I'll leave that to you. All right, so again, you don't write plus or minus. You got to separate them. 1 plus 1/2 times I, all right, comma, and that's not a lot of typing. So 1 minus 1/2 I, and there you go. There should be the two valid solutions of that equation. Wonderful. Okay. Next. All right, one last one here, it looks like, for the quadratic formula. And yet again, we have something where we have to do a very quick multiplication here and get it into standard form. So let's flip this over. All right, so we're given the equation y times the quantity 2y plus 1 plus 10 equals 0. Distribute the y. 2y squared plus y plus 10 equals 0. And now I can use the quadratic formula. Y equals, the opposite of b, which would be, b is 1, so it's negative 1, plus or minus the square root of b squared, 1, minus, 4 times a times c. ac is 20, 4 times 20 is 80, this is minus 80, another negative discriminant. And then the denominator, 2 times a, 2 times 2 is 4. This is the square root of negative 79, which would be just the square root of 79 times I. So I'm left with negative 1/4 plus or minus the square root of 79 divided by 4 times I, right? These are the two solutions. Sorry I rushed that, but I've already done 3 of these for you. All right. They're all the same. Just plug in the A, B, and C, simplify to the best of your abilities, right? You should be able to do these. All right, and I'm pretty sure 79. Yeah, that doesn't break down any further. All right. So we should be good. All right, so let me enter those. Negative 1/4 plus the square root of 79 divided by 4. Now make sure the divided by 4 is not in the square root, right? Times I. Same thing with the I. Make sure that's not in the square root. Comma. And again, I'm just going to copy and paste this after the comma. and replace the plus with a minus, and those should be good. Wonderful. All right, so that objective's done. All right, then the rest of it, the only questions left are on just that discriminant. All right, so now again, they're giving us an equation here that's already in standard form. I'm just going to say this out loud. All right, I've already done 2 of these. B squared is 4. Now AC would be positive 3, negative 1 times negative 3. 4 times 3 would be 12. 4 minus 12 would be negative 8. The discriminant is negative. Again, you're going to have imaginaries. 2 non-real solutions, complex numbers with an imaginary part, non-real. Right? They're wording it as non-real this time. So again, you see the discriminant's negative 8. Negative. All right, then the final question, again, I'll probably just do this out loud. You know, it's in standard form already, so I can talk about the discriminant, the quadratic formula, whatever. B squared is 25. Now AC would be negative 3. 4 times negative 3 is negative 12. 25 minus negative 12 would be 25 plus 12. 25 plus 12, that's 37. Now 37 is not a perfect square. 36 is. So it's positive and not a perfect square. You have 2 irrational solutions, kind of like that first example from this objective earlier. Right. And again, please read through the answer explanations. And that should be it for the preview of this assignment. As I was saying at the top of the video, right, the questions I've done here may or may not be the exact same questions you see when you work on the assignment yourself, but the objectives are the same, so the types of questions should be similar. The way you work on them should be the same way I worked on them. You might see, again, different scenarios than I did. You might actually see a discriminant that is a perfect square, and then you have 2 rational solutions instead, right? Whatever. All right, so I'm hoping that watching me go over these examples here help you in some way when you're working on the assignment yourself. And thank you very much for watching.